Okay, so welcome back, and now what we're going to do is we're going to do an example that proves the theorem, or demonstrates the theorem, right? So we use two lemmas to prove this, okay? This theorem. Okay, so now we're going to use this example, okay, to illustrate that. Okay, so now what we're going to do is we're going to use Gauss's method, okay? And again, you could change this to a matrix. So this is going to be what? It's going to be 1, 2, negative 1, 1, 2, 4, 0, 2, 0, 1, negative 3, 0. And so now we're going to use Gauss's method to reduce this. So let's take negative 2. So negative 2 plus this, right? So we're going to do, so negative 2 row 1 plus row 2. And what do we do? Well, the first row is going to remain unchanged, so that's going to be 1, 2, negative 1, 1, 0. Well, okay, negative 2 times 2 is negative 4, plus 4 is 0. And then this is also going to be, this is going to be negative 2, negative 2, so that's going to be 2 plus 0 is 2, so this is going to be 2. And then negative 2 plus 2 is 0. And then, of course, the bottom row remains unchanged. 0, 1, negative 3, 0. And so now, what are we going to do? We're going to swap, right? Swap these two rows. And what do we get? We get 1, 2, negative 1, 1, 0, 1, negative 3, 0, 0, 0, 2, 0. Okay, now we have it in echelon form. And now we can see that this has the general solution here is a single set, or excuse me, a singleton set. And you can see that because what does this tell you? This is telling you what? That z is equal to 0. Right? This is equal to 0. So if z is equal to 0, then this is going to be 0. So y is going to equal what? 3 times 0, which is 0. So y equals 0. And then, of course, if these two are 0, then what do you have? You have what? You have, this is 0, this is 0, you get x is equal to 1. So x is equal to 1, and that's your solution. So your solution set comprises of just one single vector, 1, 0, 0. Okay? Now, obviously, it's a particular solution, right? Now, what's the associated homogeneous system reduces by the same operations. Okay? So if we take the associated homogeneous solution, right? So all that's going to change is this, right? So we're going to have 0, 0, 0, right? So what happens here, if these are all zeros, well, these are just going to be zeros, right? They're never going to change, right? So hopefully you've been seeing this pattern as we've been doing these. And so what happens? Well, then this just becomes the single set of just the zero, the trivial set. So as discussed at the start of this subsection, in the single solution case, the general solution case results from just taking the particular solution and adding it to the unique solution of the associated homogeneous system, and then we're done. Okay, that's it. Have a great day.